There is a place in our solar system where mathematics becomes music, a place where gravity, the most fundamental force in the cosmos, composes a symphony of impossible beauty written in ice and light. You are looking at the rings of Saturn, the celestial masterpiece that has captivated humanity since we first turned our telescopes to the sky. They appear as a solid, serene structure, a perfect, glowing band, hung in the blackness of space like a divine ornament. But this magnificent illusion of stillness betrays a profound and deeply chaotic truth. For these are not solid bands at all. They are a river of worlds, a torrent of countless individual particles from motes of dust finer than smoke to icebergs the size of mountains. Each one is on its own independent orbit around the gas giant, a cosmic dance choreographed by the planet's immense gravitational pull. This is a realm of staggering scale and bewildering complexity. If you were to stretch the rings out from one end to the other, they would not fit in the space between the Earth and the Moon. Yet for all their breathtaking breadth, they are astonishingly impossibly thin. In most places, this colossal structure is no thicker than a 10-story building. It is a sheet of cosmic parchment 100,000 miles wide, yet so diaphanous that starlight can pierce right through it. For 400 years, we have studied this system believing we understood the fundamental rules that governed its existence. We discovered the shepherd moon's tiny gravitational anchors, like Prometheus and Pandora, that patrol the edges of the rings, their subtle influence herding the stray particles of ice, sculpting the sharp, clean lines we see. We learned of orbital resonance, the rhythmic gravitational nudges from Saturn's larger moons, like Mimas, which carve out the great dark gaps like the Cassini Division, sweeping whole regions clear of debris with the patient, inexorable force of a celestial broom. This was a clockwork universe, a place where every motion, every gap, every ripple could be explained by the local players in this grand drama. It was a family affair, a closed system of a planet, and its children locked in a gravitational embrace that was both elegant and predictable. We believed we had the full score to this celestial symphony. We were wrong, because in the silent, ordered perfection of the rings, a new and discordant note has appeared. It began as a whisper in the data, a subtle anomaly that at first our finest instruments and sharpest minds dismissed as noise. Look closer. Past the shimmering grandeur of the A and B rings out toward the fainter, more tenuous structures, like the F ring, that delicate braided strand of ice that has always been known for its bizarre and chaotic behavior. But this is different. This is not the familiar localized chaos we have come to expect. What we are witnessing is a shudder, a tremor running through the system on a scale we have never documented before. Imagine a perfectly still pond its surface like glass. Now imagine a single phantom finger touching its center. Ripples begin to spread not from the edge, but from within, propagating outward in ways that defy the known physics of the pond itself. This is what our probes and telescopes are now seeing at Saturn. We see vertical corrugations, waves that lift the ring particles up and out of the flat plane, like a flag fluttering in an unfelt wind. We observe strange periodic bunching in regions thought to be uniform, clumps of ice and dust gathering and dispersing with a rhythm that matches no known moon, no predictable resonance. It is a gravitational ghost haunting the machine, a subtle but persistent pull that is warping and twisting this celestial wonder in ways that the established models simply cannot account for. For years, the world's leading planetary scientists have worked tirelessly to solve this deepening mystery, to identify the source of this disturbance. The first and most obvious suspects were Saturn's own family of moons. Perhaps a previously undiscovered moonlet was hiding within the rings, its gravity churning the ice around it into these strange new patterns. Exhaustive searches were conducted, scanning every pixel of data, every shadow, every gravitational flicker for a hidden culprit. Nothing. The system was clean. The next hypothesis pointed to the larger, more distant moons. Could Titan, that colossal world, larger than the planet Mercury, be exerting a more complex, long-range influence than we had calculated? Or perhaps Iapetus, with its strange inclined orbit, was creating a subtle periodic pull, gravitational echo that only became apparent over the course of decades. Teams of astrophysicists ran incredibly complex simulations modeling every known gravitational interaction within the Saturnian system down to the millimeter. They mapped the intricate web of forces, the constant push and pull between dozens of moons and the planet itself. Yet every single simulation, every model based on the known objects in orbit around Saturn failed. They could not replicate the specific signature of the disturbance. The frequency was wrong. The amplitude was off. The ghost remained at large, its influence undeniable, its origin a complete unknown. The problem was that the disturbance felt alien. It did not follow the familiar cyclical patterns of an object locked in a stable orbit within the system. Its gravitational signature was transient, a long, slow pull that swelled and then began to fade like the wake of a ship that had already passed by. The answer, it seemed, was not to be found inside the system at all. The answer was coming from the chilling, unimaginable darkness between the stars. Then a discovery was made, one that seemed at first entirely unrelated. On the digital screens of an observatory in Hawaii, a faint, fuzzy smear of light was flagged by an automated survey. Astronomers followed up, tracking its movement against the fixed backdrop of the distant stars. What they found sent a jolt through the entire scientific community. The object's trajectory was not a closed ellipse, the gentle repeating curve of a planet, an asteroid, or a comet belonging to our Sun. Its path was a hyperbola, an open-ended arc that screamed of immense velocity and an origin far beyond the gravitational grip of our star. This was a traveller, a wanderer from interstellar space. It had journeyed for millions, perhaps billions of years through the cold, lonely void between solar systems. A cosmic time capsule ejected from a star we will never know, from a planetary system we will never see. It was given a designation, a name, that would soon become synonymous with one of the greatest puzzles in modern astronomy, 3I, Atlas. The I stands for interstellar, only the third such object ever confirmed to have visited our solar system. A tiny speck, likely no more than a few kilometers across. A dirty, frozen snowball silently hurtling through our celestial neighborhood at a blistering speed of over 100,000 miles per hour. It was a fascinating curiosity, a rare chance to study a piece of another star system up close before it vanished back into the abyss forever. But it was just that, a curiosity, a tiny, fleeting visitor passing through a system dominated by giants. Its path would take it far from Saturn, a distant flyby measured in hundreds of millions of miles. No one, not for a moment, considered it anything more than a footnote in the grand story of our solar system. Until one researcher working late into the night on the intractable problem of Saturn's rings had an idea that was either madness or genius. What if the phantom pull, the gravitational ghost, wasn't a ghost at all? What if the ship that had passed in the night, leaving its strange wake in the rings, was this very interstellar visitor? The idea was on its face absurd. It was a violation of everything we thought we understood about gravity and the dynamics of scale. How could an object so small, a mere pebble in the cosmic ocean, exert any measurable influence on a structure as vast and massive as the rings of Saturn? And from such a breathtaking distance, the gravitational force of 3I, Atlas at, that range would be infinitesimal, a whisper in a hurricane A, single grain of sand added to a mountain. It should have been utterly, completely drowned out by the overwhelming gravitational presence of Saturn itself and its dozens of powerful moons. It was like suggesting a passing butterfly could cause a tidal wave on the other side of the planet. It defied common sense. It challenged the very foundations of celestial mechanics, and yet when the team ran the numbers, a sudden, chilling silence fell over the room. They modelled the precise trajectory of 3I, Atlas, as it swept through the outer solar system. They calculated the faint, almost imperceptible gravitational resonance it would create as it passed. They factored in its velocity, its angle of approach, its duration of influence, and on their screens a new simulation began to run. A simulation of Saturn's rings, not just under the influence of its moons, but with the added impossibly tiny pull of this alien wanderer. Slowly, as the virtual object flew by, a familiar pattern began to emerge. A vertical corrugation appeared in the outer rings. A strange periodic bunching of particles began to form and dissipate. The simulation was producing the exact same ripples, the same tremors, the same discordant note that we were observing in reality. The ghost had a name. we are now standing at the edge of a profound scientific precipice. We have visual proof of an anomaly in the most beautiful structure in our solar system. We have a culprit, an interstellar intruder, whose calculated influence perfectly matches the crime. But the connection itself seems to break the laws of scale, pushing our understanding of gravity into a strange and uncharted territory. Could it be true? Could a tiny frozen remnant from another star passing millions of miles away truly be pulling on the rings of Saturn with enough force to be seen? Is there a mechanism of gravitational resonance, a form of cosmic amplification that we have never before understood? Or does this point to something even more profound about the nature of these interstellar objects themselves? Are they denser than we imagine? Do they possess properties that our current theories cannot explain? This is more than just an astronomical curiosity. It is a challenge to our most fundamental assumptions about the universe. It suggests that solar systems are not isolated islands, but are connected by invisible gravitational threads, and that even the smallest visitors can leave their mark on the grandest of giants. The evidence is laid before you. The mystery is posed. To find the answer, we must now follow this ghost back into the darkness. We need to understand the precise mechanics of this impossible connection to dissect the moment of this gravitational handshake between a visitor and a king. Our journey will take us deep into the mathematics of chaos and order, and to the very limits of what we can observe. For if 3i, Atlas, is truly pulling on Saturn's rings, then the silent void between the stars is not so empty after all. It is alive with whispers, echoes, and influences that can shape the destiny of worlds, and we have only just begun to listen. How long can a masterpiece last? If you were to paint a grand canvas, a work of art spanning hundreds of thousands of kilometers, but fashioned only from dust and frost, how could it possibly endure? How could such a delicate creation survive? The relentless gravitational tides, the constant bombardment of cosmic debris, and the sheer unending passage of billions of years. This is the grand and unsettling paradox of Saturn's rings. We see them as a symbol of permanence, an icon of the placid and eternal clockwork of the heavens. Yet everything we know about physics tells us they should be gone. They should have faded, collapsed back into the planet, or been scattered to the void ages ago. But they are still here. A shimmering, impossible ribbon of light, a testament to a set of physical laws so exquisitely balanced, so perfectly tuned that it borders on magic. To understand the mystery that is unfolding there now, you must first understand the miracle of their existence. You must journey into this river of ice and comprehend the forces that give it shape, the silent choreographers that guide its every particle. Our relationship with this spectacle began in confusion. When Galileo Galilei first turned his rudimentary telescope towards Saturn in 1610, he did not see rings. He saw something baffling, something his mind, steeped in a world of perfect celestial spheres, could not process. He sketched a central globe flanked by two smaller ones, like a planet with handles or ears. For decades, these strange appendages remained an enigma, shifting and even disappearing as the planet's tilt changed relative to Earth. The truth was far grander and far stranger than anyone could have imagined. It took the superior optics of Christian Huygens almost half a century later to resolve the mystery. It was not a trio of spheres, but a thin, flat ring encircling the planet without touching it, a concept so alien that he first published it as an anagram, a coded message to secure his discovery while he confirmed his findings. His revelation transformed Saturn from a planetary oddity into a celestial wonder. And then came Giovanni Cassini, who peered even deeper. He discovered that Huygens's single solid band was in fact multiple rings, separated by a dark, empty space. This feature, which we now call the Cassini Division, was the first clue that this was not a solid object, but a system of immense complexity, a place with structure, with rules. What we see today through the eyes of the Voyager probes and the magnificent Cassini orbiter is a vision that would have shattered their worlds. We see not 3 or 4 rings, but thousands upon thousands of concentric ringlets, each a distinct path in a cosmic dance. The entire structure is a celestial phonograph, its grooves and gaps encoding the gravitational story of the entire Saturnian system. And the needle that plays this music, it is the combined influence of gravity, resonance, and the tireless work of dozens of moons. The rings themselves are almost nothing. If you were to gather up all the material that composes this vast, radiant structure and squeeze it into a single sphere, you would create an object barely 400 kilometers across, smaller than many of the moons that patrol this very domain. They are 99.9% pure water ice, a blizzard frozen in time and space, with particles ranging from the size of a mote of dust to the scale of a mountain. Some are pristine, crystalline structures that glitter in the faint sunlight, throwing rainbows across the void. Others are older, dirtier, coated with organic compounds and silicate dust gathered over the eons. And they are not stationary. Each individual particle is an independent moon orbiting Saturn according to the same laws that govern the planets around the Sun. Those closer to Saturn speed along faster than those further out, a constant state of shearing and overtaking that should by all rights create chaos. Collisions are constant. A particle might orbit peacefully for thousands of years, only to be struck by another shattered into smaller pieces, or perhaps gently nudged into a slightly different orbit. It is a system in a perpetual state of grinding itself down, a beautiful slow-motion act of self-destruction. This is why their structure is so profound a puzzle. It's not a cloud, it's a tapestry. The main rings we see from Earth are labelled from the outside in A, B and C. The B ring is the brightest, broadest and most massive, a region so densely packed with ice that it is nearly opaque. Here, the endless, gentle collisions create ephemeral, transient structures, spiraling density waves that look like ripples in a pond propagating outwards for thousands of kilometers before fading away. They are gravitational traffic jams, temporary gatherings of material that give the ring a clumpy, uneven texture. Flanking it is the A ring, less dense and marked by its own strange features. And inside, closest to the planet, is the C ring, so faint and transparent it is often called the crepe ring, a ghost of a structure where the ice particles are much sparer, and between them lie the gaps. The famous Cassini Division, separating the A and B rings, is not entirely empty. It's a sparsely populated region, a cosmic desert over 4,000 kilometers wide, holding its own faint, dusty ringlets. But why is it there? Why should this specific region be so devoid of material when the areas on either side are so rich? The answer lies not within the rings, but far beyond them. The architect of this grand division is a moon named Mimas. A battered, cratered sphere of ice orbiting Saturn at a great distance, Mimas seems entirely disconnected from the ring's intricate dance. But it is a silent partner, a gravitational metronome. A particle orbiting in the inner edge of the Cassini Division will circle Saturn exactly twice for every single orbit Mimas completes. This perfect 2-to-1 ratio is called a resonance. Imagine pushing a child on a swing. If you push at random moments, you achieve very little. But if you time your push to match the swing's natural rhythm, a series of small, gentle inputs can build up to a huge effect. This is precisely what Mimas does. Every 2 laps, a particle in that specific location gets a tiny, precisely timed gravitational tug from the moon. Over millions of years, these repeated nudges have destabilized the orbits of any particles that once lived there, either flinging them into the B ring, pushing them out into the A ring, or sending them on a collision course with Saturn itself. Mimas, the distant conductor, has used the subtle power of resonance to sweep this entire region clean, carving the most prominent feature of the ring system with an invisible hand. This is the secret language of the rings. Everywhere you look, you find this story of moons and resonances repeated, creating structure out of chaos. Far out in the A-ring, you can find the Encke gap, a much narrower but incredibly sharp-edged void, and patrolling right in the middle of it is the tiny moon, Pan, just 35 kilometers across. Pan is a gravitational snowplow. As it orbits, its gravity clears a path, absorbing some material and shoving the rest aside, creating 2 bright, sharp edges to the gap it inhabits. Just next door, the even smaller moon Daphnis carves the Keeler gap. But Daphnis does more than just clear a path. Its orbit is slightly inclined, meaning it bobs up and down as it travels. As it does, its gravity pulls on the edges of the gap, sculpting them into breathtaking vertical waves, beautiful scalloped curtains of ice that tower kilometers above and below the ring plane. These are the shepherd moons, the gardeners of Saturn, tirelessly sculpting and refining the cosmic architecture. Perhaps the most bizarre and dynamic feature of the entire system is the F-ring, a thin, thread-like ring that lies just outside the main A-ring. The F-ring refuses to obey the rules. It is a twisted, braided, clumpy ribbon of ice that changes its shape in a matter of hours. This chaotic behavior is orchestrated by two more shepherds, Prometheus and Pandora, which orbit just inside and outside of it. Prometheus, the inner shepherd, periodically dips into the F-ring, its gravity pulling out long streamers of material and creating knots and kinks. Pandora, the outer shepherd, then tugs on these features, adding to the complexity. The F-ring is a laboratory for gravitational dynamics, a place where we can watch the laws of celestial mechanics play out in real time, creating a structure that is constantly being torn apart and reformed. It is a system of profound and delicate order, maintained by a complex web of gravitational pushes and pulls a dance that has been refined over geological time. We learned to read its patterns to understand its rhythms. We believed we had accounted for every major force, every significant actor in this self-contained universe. The rings were a closed system, a known quantity, into this ancient clockwork, into this place of predictable cycles and exquisite balances. Something new was coming. Something that did not belong. On September 5, 2017, the astronomers working with the Atlas survey, the Asteroid Terrestrial Impact Last Alert System in Hawaii, flagged a faint, fast-moving object. At first, it seemed unremarkable, just another speck of cosmic debris on a long journey through the solar system. But as observatories around the world turned their gaze upon it and began to plot its course, a startling realization dawned. Its trajectory was all wrong. Unlike the planets, comets and asteroids of our solar system, which orbit the Sun on relatively flat elliptical paths, this object was on a hyperbolic trajectory. It was moving too fast to be gravitationally bound to our Sunday. It was not looping back around. It was a visitor on a one-way trip just passing through. This was only the second interstellar object ever detected in our solar system. It was given the designation 3I, Atlas. The I stands for interstellar. This single letter changes everything. It means that this object is a refugee from another star system, a piece of a world that formed in orbit around a different sun. We have no idea which one. We can't trace its path back to a specific point of origin. The galaxy is a swirling, chaotic place, and its journey has been too long. It is a cosmic castaway, a messenger from an unknown shore. It has likely been traveling for millions, perhaps billions of years, adrift in the unimaginable cold and dark of the interstellar void. It is a shard of another place's history hurtling through our home. Imagine the journey. Fired from its home system by some long-forgotten gravitational encounter, it tumbled through the darkness between the stars, a realm where the nearest object is light years away. For eons, it was subject to only the faintest whispers of galactic gravity, its path almost a perfectly straight line through the cosmos. Then, by sheer dumb luck, its trajectory intersected with our own small, insignificant solar system. It fell into our sun's gravity well, not as a captive, but as a projectile. The sun's gravity bent its path, pulling it into a wide, sweeping curve that would sling it through the planetary region before flinging it back out into the interstellar dark, never to return. And the path it took was extraordinary. It did not enter along the ecliptic, the flat plane where all the planets orbit. Instead, it came screaming in from above, plunging down through the solar system at a steep inclination, crossing the paths of the planets at a sharp angle. Its speed was immense, over 40 kilometers per second relative to Saturn, a velocity born not of our sun's gravity, but of the momentum it carried from its ancient violent birth. And here is where the story shifts from a scientific curiosity to a profound, system-shattering mystery. This tiny object, 3I, Atlas, estimated to be no more than a few hundred meters across a speck, a grain of sand, an absolute nothing compared to the moons of Saturn, was on a direct course to pass through the ring plane. This fact alone was an astronomical novelty, but nothing more. The rings are vast, but mostly empty space. The probability of a direct collision with a sizable particle was minuscule. The object would slice through the gossamer-thin plane and continue on its way, a fleeting and insignificant event. But that is not what happened. As 3I, Atlas approached as it prepared to make its transit, our instruments, honed by decades of studying this system, detected something that should not be possible, something that defies our models of gravity. The rings, this immense structure 250,000 kilometers wide, held in a delicate balance by moon-sized anchors and planetary gravity, began to respond. They were reacting to the passage of this microscopic intruder. It was the equivalent of a single grain of sand dropped from a great height, causing a tidal wave in the middle of the Pacific Ocean. It was a whisper in a hurricane. It was impossible. A tiny, fast-moving rock, a ghost from another star, was pulling on the rings of Saturn, and we have the pictures to prove it. And so the gauntlet was thrown down, a challenge whispered across the gulf of space. Could a phantom, an interstellar interloper, moving with unimaginable speed, truly leave its fingerprints upon the most majestic structure in our solar system? To find the answer, we couldn't just look up at Saturn with fresh eyes. We had to look back in time into a digital ghost of the planet itself, a legacy of ones and zeros bequeathed to us by a faithful robotic explorer. The search for proof began not in the eyepiece of a telescope, but in the quiet, climate-controlled hum of a server farm. Here, within petabytes of archived information, lies the complete life's work of Cassini. For 13 years, that devoted machine spiraled and danced through the Saturnian system, its instruments capturing the rings with a fidelity we may not see again for a generation. It saw them backlit by the sun, their thinnest components glowing like celestial dust motes. It measured the temperature of their constituent ice crystals, and it listened to the crackle of plasma as they carved their path through Saturn's magnetosphere. Cassini gave us the definitive portrait of the rings, a baseline of cosmic perfection, and it was against this very perfection that scientists would search for a flaw, an unexpected wrinkle in the fabric of this grand spinning disk. The task was monumental, akin to searching a billion-page library for a single misplaced comma. A team at the Mauna Kea Astrophysical Institute, led by the tenacious Dr. Harris Thorne, believed the comma was there waiting to be found. They weren't looking for a cataclysmic scar or a gaping hole. The influence of 3I, Atlas, they theorized, would be far more subtle. It would be a whisper, not a shout, a fleeting shadow in the data, a disturbance so faint it would have been dismissed as noise by the mission's original science teams, who had no reason to be looking for the gravitational echo of an object they didn't even know existed. Their quarry was a ghost, and they were hunting it in a digital graveyard. Their method was painstakingly direct. They synchronized Cassini's entire observational timeline with the newly calculated trajectory of 3I, Atlas. They knew precisely when the interstellar object had made its closest pass, an encounter that occurred millions of kilometers from the rings themselves, but one whose gravitational gradient Thorne's models predicted would be just enough. They partitioned the vast archive into two epochs, the before and the after. The before was their control, years of serene, predictable ring dynamics, a system governed by the familiar clockwork of its moons and the central mass of Saturn. The after was their hunting ground, a narrow window of observations taken in the weeks and months following the interstellar flyby. For 18 months, their sophisticated algorithms churned through the data, comparing, contrasting, and flagging the slightest deviations from the established norm. The computers cross-referenced high-resolution images from Cassini's imaging science subsystem with gravitational resonance maps and particle density readings. They built a 4-dimensional model of the rings, 3 spatial dimensions plus time, and then virtually superimposed the path of 3I, Atlas, upon it. The team endured false positives, dead ends, and the creeping doubt that accompanies any bold hypothesis. Colleagues in the planetary science community were politely skeptical. The rings, they argued, were a chaotic place, constantly being shaped by the planet's armada of moons. Any small perturbation could be explained by 100 different local phenomena. Finding an interstellar signature would be impossible. And then one Tuesday morning in late October, the ghost appeared. It wasn't in the majestic sweeping expanse of the A or B rings, the ones we see from Earth. It was hidden away in a quieter, more delicate neighborhood, the F ring. This is Saturn's strangest appendage, a narrow, ever-shifting ribbon of ice shepherded by two tiny moons, Prometheus and Pandora. The F-ring is a place of beautiful chaos known for its braids, its kinks, and its transient knots. It is in essence the system's most sensitive seismograph, a filament so gravitationally delicate that it reacts to the slightest nudge. And in a sequence of images taken by Cassini 7 weeks after 3I, Atlas's nearest approach doctor, Lena Petrova, Thorne's lead research fellow, saw something that had never been seen before. It wasn't a bright clump or a dark channel. It was a subtle, coherent vertical corrugation. Imagine a silk ribbon lying flat on a table and then running a finger underneath it. The ribbon would rise and fall in a wave that travels along its length. This is what they saw in the F-ring. For a stretch of nearly 80,000 kilometers, the entire ribbon of ice particles, normally confined to a razor-thin plane, was oscillating up and down. This was not a kink or a braid. This was a wave of pure vertical displacement, lifting particles hundreds of meters north of the ring plane before they fell back south. A gentle, silent swell on an ocean of ice. They named it the Thorne-Petrova disturbance. The team frantically checked their work, their hearts pounding with a mixture of elation and terror. Could it be an instrumental artifact, a glitch in Cassini's camera? They pulled up simultaneous data from the visual and infrared mapping spectrometer. It showed a corresponding temperature variation in the same location, a slight warming of the ice crystals caused by the increased frequency of collisions as they were jostled up and down by this mysterious wave. It wasn't an artifact. It was real. Next, they checked for the usual suspects. Could Pandora or Prometheus, the shepherd moons, have caused this? Their models screamed no. The shepherds create localized, messy structures. This wave was too long, too elegant, too coherent. It moved through the ring material like a pure musical note, not the chaotic percussion of a local impact. It had the signature of a single, powerful but distant gravitational impulse. The timing was the final damning piece of evidence. They combed through every F-ring observation in the entire Cassini archive, all 13 years of it. Nowhere in the before epoch did a structure like this ever appear. It existed only in the after images, and it was slowly, predictably damping out over time, like the ripples on a pond, just as their models of a distant gravitational flyby predicted. The F-ring had rung like a bell struck by the gravity of an object from another star. For the first time in human history, we had recorded a direct physical interaction between our solar system and a piece of the galaxy beyond. This was the photograph of the ghost, but science demands more than a single image. It requires a body of evidence. If 3I, Atlas, had perturbed the delicate F-ring, surely it must have left its mark elsewhere. Thorne and Petrova widened their search, armed with the precise signature of the disturbance they now knew how to look for. They turned their attention inward to the dense and chaotic B, ring the brightest and most massive of all of Saturn's rings. Here, the dynamics are dominated by gravitational resonances with the moon Mimas, which creates spectacular wave-like patterns called density waves. These are well-understood phenomena, the regular rhythm of the ring's heartbeat. The team's algorithms, now retrained to look for anomalies, began to meticulously subtract this regular heartbeat from the Cassini data, searching for a fainter arrhythmic pulse hiding underneath. What they found was even more subtle than the F-ring corrugation, but just as profound. Embedded within the grand, sweeping density waves generated by Mimas, they isolated a second set of waves, much smaller in amplitude and with a completely different wavelength. These were not the majestic rolling swells of a nearby moon's influence. These were microwaves, tiny ripples only detectable through intense signal processing. And when they traced their origin, they didn't point back to Mimas or Enceladus or any other moon. The geometry of their propagation pointed to a single point in space far outside the Saturnian system, the very point where 3I, Atlas, had passed months earlier. It was as if a powerful speedboat, Mimas, was churning the water, while a pebble dropped far away, 3I. Atlas had sent a faint, almost imperceptible ripple that could only be seen by carefully analysing the interference patterns. The discovery sent shockwaves through the astronomical community. Thorne and Petrova published their findings in a landmark paper, complete with the haunting images of the F-ring oscillation and the complex graphs showing the faint anomalous waves in the B ring. The evidence was compelling, the analysis meticulous. The reaction was immediate, and it was explosive. It split the world of planetary dynamics down the middle. On one side were the exhilarated visionaries. They saw this as the dawn of a new era. For them, Saturn's rings were no longer just a beautiful static feature of our solar system. They were an active observatory, a vast natural gravitational wave detector. If they could record the passage of a small object like 3I, Atlas, what else might be written in their intricate grooves and ripples? Could we find evidence of other, older interstellar passers-by? Could the rings hold a record of our solar system's journey through the galactic arm, a logbook of its encounters with interstellar clouds or dark matter clumps? The rings they proposed were a celestial Rosetta Stone, and we were finally beginning to learn the language. But on the other side stood the cautious, disciplined skeptics. They did not dispute the data. The Thorne-Petrova disturbance was undeniably real. They disputed the interpretation. The Saturnian system, they argued, is an engine of immense complexity. There are dozens of moons, each with its own gravitational song. There are resonances within resonances, chaotic orbits, and poorly understood electromagnetic effects. They pointed out that new structures like the propellers created by tiny unseen moonlets were being discovered in the rings all the time. To attribute this single new phenomenon to an exotic interstellar cause, they claimed was a leap of faith, a violation of the principle that extraordinary claims require extraordinary evidence. Show us a mechanism, one prominent dynamicist wrote in a scathing critique, that is not just plausible but necessary. Eliminate every other possibility, no matter how remote, before you invoke a visitor from the stars. The skeptics' most pointed criticism focused on the nature of the interaction itself. Standard Newtonian gravity, they calculated, just wasn't strong enough. Even with its high velocity, an object the size of 3I, Atlas, passing millions of kilometers away, shouldn't have been able to produce a vertical wave of that magnitude in the F ring. The numbers didn't add up. The cause and effect relationship was weak. The ghost was in the photograph, but the physics of how it had impressed itself upon the film remained a profound mystery. Was the object far more massive than we believed? Unlikely, as its trajectory would have been different. Did it possess some unknown property, some bizarre interaction with Saturn's magnetic field? Or was our understanding of gravity on these delicate scales somehow incomplete? This, then, was the crux of the debate. The visual proof, once a tantalizing goal, was now in hand. We could see the effect. We had the before and the after. We had the anomalous wave in the F ring and the corresponding ripples in the B ring. But in finding the evidence, we had stumbled into a much deeper and more unsettling puzzle. The proof itself had become a paradox. The rings were telling us a story, but it was a story our physics could not yet read. The clear, beautiful evidence of the disturbance had not closed the case. Instead, it had thrown open the doors to a dozen new questions, each more complex than the last. What was the true nature of 3I, Atlas? What was this interstellar wanderer that it could reach across such a void and pluck the strings of Saturn with a force our equations could not explain? The search for a simple gravitational fingerprint had failed. It had instead uncovered a bizarre and enigmatic handprint, one that hinted at a type of interaction we had never before considered. The visual evidence was no longer the end of the story. It was the beginning of a far stranger investigation, one that would take us from the icy particles of the rings to the very heart of gravitational theory itself. The ghost was real, but now we had to understand how it had learned to touch our world. For a breathless moment, it seemed physics itself was broken. The image, that ghostly fingerprint of an impossible force, had gone viral not just on our screens but through the very soul of astronomy. 3I, Atlas, the interstellar vagabond, was seemingly reaching across a chasm of millions of kilometers, with a visible gravitational hand physically pulling at the rings of Saturn. It was a beautiful, terrifying, and exquisitely simple idea. And for that reason, we should have known it was probably wrong. Science, after all, rarely whispers its greatest truths so plainly. The universe is a far more subtle beast. The first response wasn't disbelief, but a global, coordinated, and almost frantic mobilization of resources. Every major observatory capable of turning a lens towards Saturn was commandeered. The European Southern Observatory's very large telescope, nestled high in the bone-dry air of the Atacama, activated its adaptive optics systems. Lasers shot into the upper atmosphere, creating artificial guide stars their light, allowing computers to cancel out the shimmering dance of Earth's air. They were attempting to achieve a clarity from the ground that could rival Hubble in space, to capture not just a single snapshot, but a high-definition motion picture of the alleged crime scene. In Hawaii, the twin Keck telescopes, their segmented mirrors, working in perfect unison, began a marathon of spectroscopic observation. They weren't just looking at the rings, they were listening. By splitting Saturn's reflected light into a rainbow of its constituent parts, they could search for the telltale Doppler shifts, the subtle stretching and compressing of light waves that would betray the velocity of the ice, particles. Was one edge of the disturbance moving towards us faster than the other? Was there a rotational component, a twist in the wound? This was forensics on a planetary scale. Even Cassini, our long-dead robotic emissary to Saturn, was resurrected in spirit. Teams of the Jet Propulsion Laboratory began a feverish deep dive into its archived databanks, exabytes of information from its 13-year odyssey. They weren't looking for images of 3I, Atlas, which was long gone. They were hunting for ghosts. They were searching for any previously overlooked tremor in the rings, any faint, unexplained ripple from years past that might serve as a baseline, a control against which this new dramatic event could be measured. Was this new disturbance truly unique? Or was it merely the loudest shriek in a system that constantly hummed with activity? We were asking the system for its own history, hoping its past would illuminate its violent present. The entire astronomical community held its breath, waiting for the flood of new data that would either build the pedestal for a Nobel Prize or tear the entire sensational theory down to its foundations. Simultaneously, in climate-controlled server rooms across the globe, another kind of telescope was being aimed at Saturn. These were the leviathans of computation supercomputers that could manipulate entire universes made of pure data. In Germany and in the United States, competing teams of astrophysicists began constructing the most complex N-body simulations of the Saturnian system ever attempted. They began with a digital Saturn, a perfect gravitational anchor rendered in mathematical code. Around it, they didn't just place a few dozen rings. They populated the digital void with hundreds of millions of individual particles, each one a virtual shard of ice. Every single particle was given its own mass, its own velocity, its own orbital path governed by the cold, unforgiving laws of gravity. They were not just simulating the rings, they were building them from scratch, a celestial ghost in the machine. Into this pristine clockwork system, they introduced every known variable. The gravitational pull of Saturn's dozens of moons, from colossal Titan down to the tiny shepherd moon Pan, was meticulously programmed in. They accounted for the subtle pressure of sunlight, the faint push of photons that can over millennia alter the orbits of ice crystals. They even factored in the faint but persistent pull of Jupiter, the system's distant domineering cousin. For weeks, these digital Saturns spun in silence, the simulations running at trillions of operations per second, confirming that their models were stable, that their virtual rings behaved exactly as the real ones did. Only then, once this perfect baseline was established, did they introduce the villain of the piece. They summoned the ghost of 3I, Atlas. They gave it the precise trajectory, the exact velocity, the estimated mass that had been painstakingly calculated from its brief terrestrial flyby. Then, with the press of a key, they sent this digital interloper hurtling through their virtual solar system. What they expected to see was a triumphant confirmation. They expected their millions of digital ice particles in the A-ring to bend and warp in perfect mimicry of the astonishing photograph that had started it all. They anticipated a clear, unambiguous gravitational signature, a digital echo of the disturbance that had captivated the world. Instead, they got silence. A profound, baffling, and deeply troubling silence. The simulation ran the hours of processing time, stretching into days. On their screens, 3I, Atlas sliced through the outer system, a phantom on its predetermined path. But in the rings, nothing happened. Nothing, at least on the scale that had been observed. There was a pull, of course. The laws of physics demanded it. Their instruments, sensitive beyond imagination, could detect a minuscule, almost infinitesimal perturbation. It was the gravitational equivalent of a single feather landing on the surface of an entire ocean. It was a tremor so faint it would be utterly invisible to any telescope ever built a whisper when the real-world evidence was screaming. The teams ran the simulation again, this time tripling the estimated mass of 3I, Atlas. Still nothing. They increased it by a factor of 10, giving the object a mass so enormous it strained credulity. A faint ripple finally appeared, but it was pathetic, a pale and malformed shadow of the majestic wound seen in the photographs. The digital ghost refused to perform as its real-life counterpart had. The models were unequivocal for 3I, Atlas, to have physically pulled the rings into that shape it would need, to have a mass comparable to a dwarf planet. It would have needed to be composed not of rock and ice, but of some impossibly dense, exotic matter that we have never encountered. The beautiful, simple theory was beginning to crack under the immense pressure of computational reality. The direct pull, the elegant, intuitive explanation was not just unlikely. According to our best understanding of physics, it was dynamically impossible. The sheer force required was absent. A sense of profound disappointment, mingled with a thrilling new current of confusion, began to snake through the global research teams. If 3I Atlas didn't pull on the rings, then what on earth or off it did we see? Just as the simulation results were casting a deep shadow of doubt, the first wave of new observational data began to arrive, and it changed everything all over again. The images from the Very Large Telescope, sharpened to a razor's edge by its laser guide stars, were breathtaking. They confirmed beyond any shadow of a doubt that the disturbance was real. This wasn't an artifact, a camera glitch, or a trick of the light. There, etched into the A-ring, was the sweeping chaotic structure, a scar on the system's perfect symmetry. But the new clarity revealed details that had been invisible before, and these details were deeply problematic for the direct pull theory. The original image had shown a smear. These new pictures showed a fine, intricate structure. The edges of the disturbance were not smooth and curved as you would expect from a simple gravitational tug. They were sharp, almost crystalline in their definition. Even more strangely, there were delicate, repeating wave patterns visible within the main disturbance, like ripples spreading from a stone dropped in a pond, but far more organized, more resonant. A simple pull from a passing object would be a smear, a one-time event. This looked less like a pull and more like a vibration, a shudder that was propagating through the ring material itself. The spectroscopic data from Keck added another layer of impossibility. The velocity measurements showed that the particles at the heart of the disturbance weren't just being pulled outwards away from Saturn, they were moving in complex corkscrewing paths, some moving up out of the ring plane while others plunged down. It was a symphony of chaos, a three-dimensional vortex of motion that a simple two-dimensional pull from a distant object could never hope to explain. The evidence was now in violent, undeniable conflict. The observations screamed that a major energetic event had occurred in the rings. The simulations screamed that 3I, Atlas, could not have been its cause, at least not directly. We had confirmed the effect while simultaneously disproving the cause we had assigned to it. It was the scientific equivalent of finding a gunpowder-scorched victim in a locked room where no gun could possibly have been fired. The entire community stood at a precipice, forced to abandon the theory that had electrified them. The narrative had to pivot. They had been so seduced by the celestial alignment, by the incredible coincidence of an interstellar visitor passing by at the exact moment a disturbance appeared, that they had latched onto the most obvious conclusion. But the universe, as it so often does, was proving to be a far more clever and imaginative storyteller. Two new, far more subtle and complex hypotheses began to emerge from the wreckage of the old one. The first was the theory of resonance. Gravity, after all, doesn't always work like a hammer. Sometimes it works like a whisper, repeated at precisely the right moment. Think of a child on a swing. A single massive shove will send them flying, but so will a series of tiny, perfectly timed pushes. If you push at the exact peak of the swing's arc over and over, that tiny input of energy builds and builds until the child is soaring. Perhaps 3I Atlas didn't need to be a sledgehammer. Perhaps it was a tuning fork. As it passed through the outer solar system, its gravity, however weak, would have created faint periodic pulses. If the frequency of those pulses just happened to match a natural resonant frequency within the A-ring, a specific orbital period where particles are especially susceptible to influence, then those tiny gravitational nudges could have amplified over time. Each passing wave of 3I, Atlas's influence, would have added a little more energy to the ring particles, pushing them just a bit further, a bit faster, until their orderly dance collapsed into the chaotic vortex we were now seeing. This would explain the sharpness of the disturbance and the intricate wave patterns. It wasn't the result of a single brutal pull, but the culmination of a gravitational song played at just the right pitch to make a specific section of the rings tremble and then shatter its own composure. It was an elegant, compelling idea, replacing the brute force of the original theory with a subtle, almost musical interaction between the visitor and the rings. The interstellar object hadn't assaulted Saturn. It had hummed a tune that Saturn's rings were uniquely vulnerable to hearing. But a second, even more audacious possibility began to haunt the edges of the conversation. It was the hypothesis of cosmic coincidence. This theory proposed that 3I Atlas was in fact a complete and utter red herring. Its passage had absolutely nothing to do with the disturbance in the rings. Instead, it suggested that by a staggering fluke of celestial timing, an entirely separate internal event took place within the rings, at the very moment our attention was drawn there by the interstellar interloper. The rings, we know, are not a static, placid place. They are a dynamic, grinding, and occasionally violent environment. Embedded within them are countless unseen moonlets, some no larger than a stadium, which we call propellers. These tiny bodies constantly carve out gaps in the ring material with their own gravity, creating structures that look like old airplane propellers. Most of these propellers are small and stable, but what if one, a particularly large and previously dormant propeller moonlet, was suddenly activated? Perhaps a collision with another, smaller body shattered it or altered its orbit, causing it to suddenly begin stirring up the ice around it with a newfound violence. It might have triggered a density wave, a traffic jam of ring material that propagates outwards like a shock wave, creating exactly the kind of sharp, complex structures the new telescopes were seeing. In this scenario, we were like detectives arriving at a house fire to find a known arsonist standing across the street admiring the view. We had immediately assumed his guilt. But the truth might be that he just happened to be passing by when the house's faulty wiring decided to burst into flames on its own. It was a deeply unsatisfying thought, one that stripped the event of its romance and its connection to the great interstellar beyond. And yet it was plausible, so the board was wiped clean. The stunning, simple answer was dead slain by the cold, hard facts of simulation and observation. And in its place stood two new suspects, two radically different explanations for the scar on Saturn's face. Was it resonance, a subtle and powerful harmony between an alien visitor and a native ring system? Or was it coincidence, a 1 in a billion chance alignment of two unrelated dramas, one playing out in the interstellar darkness and the other in the heart of the rings themselves? We had solved the first mystery, only to uncover a second, far deeper one. We now knew for certain that we had witnessed something extraordinary, but the most important question of all, the question of why, remained utterly tantalizingly unanswered. The real investigation, the one that would probe the deepest secrets of celestial mechanics, had only just begun. The easy answer, the one that fit so neatly into our textbooks, was gone. It had evaporated under the cold, hard light of mathematics. A direct gravitational pull from 3I, Atlas, a simple celestial tug of war, could not have sculpted the ghostly signatures Cassini had witnessed. The numbers were adamant, unyielding. The comet was too small, too distant, its gravitational grasp far too feeble. And so the investigation turns, as it so often does in science, away from the simple and downward into the labyrinth of the beautifully complex. This is not a path of failure, but one of profound discovery, a journey into the hidden machinery of the cosmos, where the greatest effects are often born from the most subtle of causes. The question was no longer times if times 3I Atlas was the culprit, but times how asterisk. The crime scene was secure, the suspect was in the frame, but the method, the true nature of its influence remained a deep and maddening enigma. If not a shout, could it have been a whisper timed to perfection? Planetary scientists began to look not at the raw power of the comet, but at its timing, its cadence, its rhythm as it swept through the outer solar system. They turned to one of the most powerful and often misunderstood forces in the universe, resonance. You understand this phenomenon intuitively. Imagine a child on a swing. You don't need the strength of a giant to send them soaring into the sky. All you need is a series of small, gentle pushes applied at precisely the right moment in the swing's arc. Your tiny input of energy, when synchronized with the natural frequency of the system, adds up, accumulating until the swing is flying higher than you could ever achieve with a single brutish shove. The cosmos is filled with these gravitational swings, and Saturn's rings are perhaps the most exquisitely tuned resonance system we have ever discovered. They are not a solid, monolithic object like a dinner plate. They are a shimmering, dynamic river of trillions of independent ice particles, each in its own orbit, each a tiny moonlet following Kepler's laws. And this river is not flowing in serene isolation. It is constantly being stirred and shaped by the gravitational pushes of Saturn's dozens of moons. Mimas, the Death Star moon, carves the great Cassini Division, with its relentless timed tugs clearing a vast gap in the rings like a cosmic snowplow. Pan and Daphnis, tiny shepherd moons, race along the edges of their own gaps, their gravity acting like sheepdogs herding the flock of ring particles, creating the breathtakingly sharp edges of the Encke and Keeler gaps. The entire ring system is a tapestry of these resonances, a silent symphony of gravitational beats and counterbeats. It is a system humming with latent energy filled with instabilities that are held in a delicate, beautiful balance. It is a system scientists realized that was perfectly primed for a disturbance. Into this exquisitely balanced architecture came the gravitational whisper of 3I, Atlas. The new hypothesis was as elegant as it was compelling. The comet did not need to pull the rings. It only needed to push ever so gently on one of these pre-existing gravitational swings. Its tiny, rhythmic gravitational nudge arriving from deep space might have been just the right frequency to resonate with a population of particles already being shepherded by one of Saturn's moons. It was the celestial equivalent of that perfectly timed push on the swing, the final tiny input of energy that amplified a small existing wobble into a large visible oscillation. The models required to test this were staggering in their complexity. Supercomputers were tasked with simulating not just Saturn and a single comet, but trillions of ring particles and the intricate gravitational web spun by more than 80 moons. For months, they churned through the calculations, attempting to recreate the delicate dance of forces that might have occurred as the comet made its distant passage. The goal was to find a resonant window, a moment in time, and a location in the rings where the comet's influence, however faint, could have tipped the scales. The initial results were electrifying. The simulations showed that under certain conditions, a distant perturber could times indeed amplify existing spiral density waves within the A and B rings. These waves, normally faint and tightly wound, are the visible expression of gravitational resonances with nearby moons. The models suggested that the comet's influence could have caused these waves to grow in amplitude to become more pronounced, effectively strumming the rings like a guitar string. This would create precisely the kind of subtle large-scale warping that Cassini's instruments had detected. It was a breakthrough, a plausible physical mechanism that connected the distant traveller to the disturbance at Saturn. Yet a shadow of doubt remained. While the resonance models could explain the general warping and large-scale structures, they struggled to account for the finest, most ethereal details in the Cassini images. They couldn't fully explain the strange, gossamer-like filaments that seemed to lift vertically out of the ring plane, or the peculiar changes in colour and brightness that hinted at something more than a simple gravitational reshuffling. The gravitational whisper theory was a powerful piece of the puzzle, but it wasn't the whole story. Gravity, it seemed, had an accomplice. The investigation had to go deeper still, beyond the invisible forces of gravity and into the tangible physical world of matter itself. So scientists shifted their gaze from the comet's core, its tiny nucleus of ice and rock, to the magnificent ghostly halo that surrounded it. A comet is not just a point of mass. It is a living, breathing object, a dirty snowball that sublimates under the warmth of the sun, shedding a constant stream of gas and dust into space. As 3I Atlas journeyed through the solar system, it was encased in its own atmosphere, a vast, tenuous cloud called the coma, which stretched for hundreds of thousands of kilometers. And trailing behind it was a tail of dust and a separate tail of plasma, stretching for millions more. For most of its journey, this ethereal debris disperses harmlessly into the vacuum of space. But the new audacious hypothesis asked a startling question. What if Saturn and its rings didn't just feel the comet's gravity, but physically flew through its ghost? What if the ring disturbances were not caused by a pull, but by a collision? The gentlest, most subtle collision imaginable. A collision not with a solid body, but with an almost imperceptible cloud of microscopic dust and ionized gas. This opened up an entirely new realm of physics, moving beyond the clean mathematics of orbital mechanics into the messy, complex world of plasma physics and electromagnetism. The celestial crime scene was suddenly contaminated with a new kind of evidence. The first part of this new theory focused on the comet's dust. These are not simple specks of dirt. Out in space, exposed to the raw, unfiltered light of the sun, tiny particles are subject to the photoelectric effect. Ultraviolet photons strike the dust grains and knock electrons loose, giving each microscopic particle a small positive electric charge. Saturn's rings, too, are not electrically neutral. They exist deep within Saturn's colossal magnetosphere, a magnetic bubble that traps charged particles and is flooded with plasma. The ice particles of the rings are constantly bombarded by electrons and ions, building up their own complex electrical charges. The rings are, in essence, an electrostatic minefield. Now picture the scene, this vast, tenuous cloud of positively charged cometary dust, millions of kilometers wide, washing over the Saturnian system. As these charged dust particles encountered the electrically complex environment of the rings, they would have interacted not through gravity, but through the fundamental force of electromagnetism. The analogy is simple, one you've experienced yourself. Rub a balloon on your hair and you can make it stick to a wall. It's not gravity, it's static electricity, a force far stronger than gravity at microscopic scales. Scientists proposed that a similar effect, magnified by trillions upon trillions of particles, could have been at play. The influx of charged cometary dust could have electrostatically repelled or attracted the finest particles in the rings, particularly in the wispy F-ring or the dusty outer belts. This force could have been strong enough to levitate the micron-sized dust grains, lifting them vertically out of the incredibly thin ring plane. Suddenly, those ghostly filaments seen in the Cassini data had a potential explanation. They weren't waves times within times the rings, but curtains of dust being lifted times above times them by an invisible electrical hand. This mechanism also brilliantly explained the changes in brightness. A fluffy, levitated cloud of dust scatters sunlight very differently than a flat, dense sheet of particles. The rings would have appeared brighter and hazier, not because there was more material, but because the existing material had been momentarily rearranged, fluffed up like a pillow. The cometary dust wasn't just a suspect, it was a potential match for the visual fingerprints left at the scene. But the dust was only half of the comet's ghostly trail. The other half was even more ephemeral and potentially more powerful, the plasma tail. This isn't just neutral gas. The sun constantly blows a hurricane of charged particles, protons and electrons into space. This is the solar wind. When this supersonic wind hits the gas, sublimating from a comet, it strips electrons from the atoms, creating a glowing stream of ionized gas or plasma. This plasma tail points directly away from the sun, a celestial windsock showing the direction of the solar gale. Saturn, as we know, has its own enormous bubble of plasma, its magnetosphere created by the planet's powerful magnetic field. The stage was set for a titanic yet invisible confrontation, the meeting of two distinct plasma environments. The comet's plasma tail, a foreign stream of charged particles sweeping directly through Saturn's homegrown magnetosphere. For the ring particles, this would have been like a storm front moving in. The finest grains, those most susceptible to non-gravitational forces, would have experienced a sudden change in their environment. They would have felt a form of pressure, a drag, as the cometary plasma flowed past them. Think of it as a current in an ocean. The larger rocks on the seafloor are unmoved, but the finest grains of sand are stirred up and carried along by the flow. The models for this are exceptionally difficult, probing the frontiers of magnetohydrodynamics, but they suggested that this plasma drag would be most effective on the smallest particles in the outermost rings. It could have been enough to gently nudge them out of their perfect Keplerian orbits, creating ripples and fine corrugated patterns like the patterns wind leaves on the surface of a sand dune. This provided another compelling match to the detailed Cassini observations explaining features that gravity alone simply could not. The case was becoming stronger, more layered, more intricate. The simple idea of a gravitational pull had been shattered, but in its place stood a far more magnificent structure, a theory built on the interplay of multiple forces of nature acting in concert. It seemed increasingly likely that 3I, Atlas, had assaulted Saturn not with a single blow, but with a sophisticated 1-2 combination punch. The final unifying theory began to crystallize in the minds of the science teams, a narrative that wove together all the disparate threads of evidence into a single cohesive story. It was a symphony of cascading effects where one subtle action set the stage for the next. First came the vanguard, the invisible wave of gravity. The comet's faint rhythmic gravitational whisper arrived not as the primary weapon but as the saboteur. It didn't need to create the damage itself, it merely needed to prepare the target. This gentle, resonant nudge found a section of the rings that was already in a delicate balance, a region humming with latent instability from the relentless tugging of Saturn's moons. The comet's whisper pushed this section just a fraction closer to the edge of chaos, priming it, weakening its structural integrity without creating any immediately obvious damage. It was the perfect setup. Then days or weeks later, the main force arrived. Not a cannonball but a fog, the vast invisible cloud of charged cometary dust and plasma, billions of cubic kilometers of ethereal matter washed over the Saturnian system. This cloud, which would have had no discernible effect on a stable, placid ring system, encountered the exact region that had been pre-weakened by the gravitational resonance. Here, in this primed and vulnerable section, the electrostatic forces and the plasma drag found purchase. The charged dust lifted the fine particles that were already loosely held, creating the glowing vertical filaments. The plasma current pushed on the grains whose orbits were already slightly perturbed, sculpting them into fine ripples and waves. The gravitational nudge had loaded the weapon, and the cometary debris cloud had pulled the trigger. One force could not have done it without the other. It was the combination, the sequence, that was so devastatingly effective. This two-stage hypothesis explained everything. It explained the timing of the event, the large-scale warping seen across the rings, and the fine ethereal structures that had so baffled investigators. It reconciled the immense distance of the comet with the intimate, tangible changes in the rings. It was a theory of breathtaking elegance and complexity, a testament to the interconnectedness of the cosmos, where gravity, electromagnetism, dust, and plasma can conspire to paint a masterpiece of transient beauty across a planetary canvas. We had a story, a powerful, compelling story that fit the known facts far better than any other. But in science, a beautiful story is not enough. A theory, no matter how elegant or all-encompassing, remains a ghost until it can be proven. It is an intellectual sculpture awaiting the spark of validation. And how could we possibly prove such a complex ephemeral sequence of events? The resonant gravitational wave left no permanent trace. The cloud of cometary dust and plasma had passed through the system and dissipated into the void millions of kilometers away. The evidence seemed to have vanished forever. To find the final conclusive proof, the smoking gun, we would have to realize that we had been looking in the right place but at the wrong victim. The rings, vast and resilient, had been disturbed, yes, but they had absorbed the blow. To find the indelible fingerprint of this cosmic encounter, we would need to find another witness, something smaller, more vulnerable, and far more sensitive to the ghostly passage of 3I, Atlas. The answer scientists began to suspect was not in the great shimmering plane of the rings, but hiding in the darkness orbiting within them. So the brute force of gravity had failed us. The elegant equations that chart the course of planets, that predict the waltz of moons, and the patient arc of comets they had broken upon the delicate architecture of Saturn's rings. Every simulation, every model, built on the simple, powerful idea of a gravitational pull, one object tugging on another across the void, produced nothing. It gave us a sterile, lifeless Saturn, its rings stubbornly inert, utterly ignoring the phantom limb of 3I, Atlas's influence. The ghost in the machine we had so eagerly chased turned out to be just that, a ghost, a figment of our own incomplete imagination. The visual proof, those haunting, ephemeral ripples captured by Cassini and our most powerful telescopes, remained an accusation, a silent testament to a universe more subtle, more intricately connected than our finest theories had yet allowed. For science, this is not a moment of defeat. It is a terrifying, exhilarating precipice. It is the moment you realize the map you have been using is missing entire continents. And from that precipice, a new kind of exploration began. Not with a single ship, but with a global flotilla of minds. The problem was too vast, the data too complex for any one institution, for any lone genius. What followed was one of the most extraordinary unsung collaborations in modern astronomy. Teams from Pasadena to Paris, from Kyoto to Cambridge, began linking their systems, pooling not just their observations but their computational power. They built a digital Saturn, a virtual laboratory of unprecedented fidelity, an entity that lived and breathed in petabytes of data across a network of supercomputers. They were no longer trying to solve a simple equation of force. They were attempting to resurrect a moment in time, to build a perfect echo of the solar system as it was during the comet's fleeting passage, and to finally understand the true nature of its whisper. The first breakthrough came not from gravity but from music, or rather its cosmic equivalent, resonance. You understand this intuitively. You've seen a child on a swing, a parent pushing at just the right moment in the arc. The pushes are small, almost effortless, but because they are timed perfectly with the swing's natural rhythm, the child soars higher and higher. The energy accumulates. This is resonance. The rings of Saturn, you see, are not a solid static object. They are a congregation of trillions of tiny moons, each in its own orbit, each with its own rhythm. They are a musical instrument the size of a planet, strung with chords of ice and dust waiting for a musician. For millennia, the only players had been Saturn's own moons, their steady gravitational nudges creating the beautiful permanent gaps and divisions we have known for centuries. The Cassini Division, the Encke Gap, these are the standing waves of a planetary symphony. But 3I, Atlas, was a different kind of musician. It wasn't a member of the orchestra. It was a transient note, a passing chord that played once and then vanished. The simulations, now incorporating these complex wave dynamics, began to stir with a new kind of life. As the digital ghost of the comet swept past the digital Saturn, the global network of scientists watched breathless as something extraordinary happened. The comet's gravitational influence, too weak to pull or tear the rings directly, was just strong enough to act like that gentle rhythmic push on a swing. It didn't need to be powerful. It just needed to be times right asterisk. Its passage excited a cascade of resonant frequencies deep within the A and B rings. Tiny, imperceptible shivers in the orbits of individual ice particles began to add up, to amplify each other, their energies constructively interfering. We were not looking for a pull. We should have been listening for a hum. The comet had softly plucked the rings, and for a few fleeting weeks they had vibrated with a ghostly energy. This explained the times, energy times of the disturbance, the source of the unexpected motion. But it did not explain the times image asterisk. Resonance is a subtle, invisible force. It is order and structure, not the chaotic, almost cloud-like apparitions that had been seared into our detectors. The visual proof, the very thing that had launched this entire investigation, was still missing from the picture. The simulations were now alive with elegant, shimmering density waves, patterns of unimaginable mathematical beauty, but they were not the structures we had seen. The map was still incomplete. There had to be another layer, another actor on this celestial stage that we had completely unforgivably overlooked. And the answer when it came was as humble as it was profound. It was dust. We had been so focused on the grand architecture of the rings, on the planet-sized ribbons of pristine ice, that we had forgotten that space is not empty. It is filled with a fine, almost imperceptible mist of micrometeoroids, a constant drizzling rain of cosmic debris left over from the formation of the solar system. Saturn is constantly ploughing through this interplanetary weather. Its rings, with their enormous surface area, act as a vast passive collector, a celestial rain gauge sweeping up tons of this material every single day. For eons, this has been a quiet, steady process, a background noise that astronomers had learned to filter out. But 3I, Atlas, in its journey from the outer darkness, had done more than just sing to the rings. It had disturbed this weather. Like a ship ploughing through a calm sea, the comet's passage and its own shedding of dust and gas created a wake, a temporary invisible turbulence in the stream of micrometeoroids flowing towards Saturn. It was a subtle gravitational scattering, a brief but significant thickening of the cosmic dust storm in Saturn's immediate vicinity. The comet, in effect, had directed a faint temporary river of debris directly into the path of the ring system. This was the missing piece. The second critical component to the puzzle. Now the global consortium of scientists had their final variable. They fed this new understanding of dust dynamics into their colossal simulation. They modelled the comet not just as a point of mass, but as a disruptive presence in the interplanetary medium. They programmed the resonant waves, the gentle humming of the rings, and then, at the crucial moment, they introduced the transient focused stream of micrometeoroids. The world's most powerful computers fell silent as they processed the unimaginable complexity of this new scenario. They were no longer calculating the interaction of a few large bodies. They were now tracking the fate of billions of individual particles, ice crystals vibrating in resonance, and microscopic dust motes striking them at hypersonic speeds. It was the digital equivalent of recreating an entire ecosystem atom by atom, and then it happened. On screens across the world, the final, beautiful, terrible truth bloomed into existence. The digital ghost became flesh. As the resonant waves amplified by the comet's passage rippled through the virtual rings, they created temporary bands of higher and lower density. The ice particles bunched up and spread out in a perfect oscillating pattern. Then the simulated micrometeoroid stream struck this energized vibrating system. When the dust particles hit the low-density regions of the wave, nothing much happened. They passed through or were absorbed quietly. But when they slammed into the high-density crests of the waves, the regions where the ice particles were momentarily crowded together by the resonance, the effect was explosive. Each microscopic impact vaporized a tiny puff of ice, creating a cloud of water vapor and charged particles. It was a celestial blowtorch meeting a vibrating crystalline wall. What we were seeing was not the ring particles themselves being thrown into disarray. We were seeing the times result, times of their hyper-organized state. The resonance wave acted as a template, an invisible grid. The micrometeoroid stream was the ink. The impacts were only lighting up the densest parts of the invisible wave, momentarily painting the crests of the resonant vibration onto the sky for us to see. Those ethereal cloud-like structures that had haunted us were not the rings themselves. They were transient clouds of vapor and plasma, blasted from the surface of the rings by a cosmic sandstorm, their shape perfectly tracing the underlying invisible resonant wave. It was a phenomenon of exquisite complexity, an interplay of gravitational harmony and percussive violence. The pull was never a pull. It was a song that made the rings vibrate and a storm that made those vibrations visible. The visual proof was a temporary scar, a fleeting atmospheric event on the rings themselves, a phenomenon that likely happens in subtler ways all the time, but was amplified to a spectacular observable degree by the unique passage of a rogue comet from the deep. In that moment, our entire conception of planetary rings was irrevocably altered. We had thought of them as ancient, almost static structures, geological features sculpted over billions of years. We saw them as beautiful fossils. But the simulation proved they are alive. They are dynamic, hypersensitive systems existing in a state of constant, delicate equilibrium. They are not just passive collectors of light and debris. They are cosmic seismographs, membranes of unimaginable scale and sensitivity, recording the faintest tremors that pass through the solar system. The passage of 3I, Atlas, was a whisper, but the rings heard it as a shout. They possess a capacity for complex, emergent, self-organizing behavior that we are only just beginning to comprehend. They are not merely debris, they are a coherent entity, a system that responds and communicates in a language of waves and dust, a language we have finally, after all this time, begun to translate. The mystery that began with a few strange smudges on a photograph has opened a door onto a new frontier, a universe not of disconnected objects, but of profound and intricate connection, where the largest structures can be shaped by the smallest whispers, and where there is still so much more to see if we only learn how to look. And so the ghost in the machine is finally revealed. Not the brute force tug of a distant comet, a phantom hand reaching across hundreds of millions of kilometers to physically pull on the rings of Saturn, as the headlines proclaimed. The truth, as it so often is, in the cosmos was something far more subtle, far more elegant, and infinitely more profound. We began this journey with a startling proposition, an idea that felt almost like science fiction. An interstellar wanderer, a fleeting visitor from another star, was actively reshaping a giant of our own solar system. It was a captivating, almost romantic notion, and it was wrong. But the real story, the one we uncovered together, is not one of simple error and correction. It is a testament to how science truly moves forward. The initial sensational claim about 3I Atlas was not a failure. It was an accidental catalyst, a spectacular misinterpretation that forced us to look at Saturn with new eyes. It lit a fire under the scientific community, prompting a frantic collective search for an explanation to a phenomenon that, without that initial spark, might have remained hidden within the noise of raw data for decades. That headline flawed as it was served as a cosmic signpost pointing us down a road we didn't know existed towards a discovery far grander than the one we were looking for. It was a classic case of searching for a needle in a haystack only to find that the haystack itself was the treasure. We have witnessed the sublime power of the scientific method in action, not as a sterile, linear process found in textbooks, but as a vibrant, dynamic, and deeply human endeavor. It began with observation, an anomaly in Cassini's priceless data, a strange new ripple in the C-ring, a faint tremor where none should be. Then came the hypothesis, bold and imaginative, linking it to Atlas. That hypothesis was then subjected to the crucible of scrutiny. As models were run, numbers were crunched, and the physics were tested. When the maths simply refused to cooperate, when the gravitational influence of the distant comet was shown to be less than a whisper against a hurricane, science did not retreat, it pivoted. The question evolved. If it wasn't the comet's direct pull, what was it? The investigation turned inward from the far-flung visitor to the very heart of the Saturnian system itself. We were forced to reconsider the rings not as a static passive structure, a mere collection of orbiting ice and dust, but as an immense, exquisitely sensitive musical instrument. An ethereal harp with strings thousands of kilometers long, tuned by the delicate interplay of gravity and orbital mechanics. And like any finely tuned instrument, it doesn't just play its own music, it resonates with the vibrations of the world around it. We had been listening for a drumbeat when we should have been listening for a symphony of whispers. The truth lay in the very structure of Saturn itself, in the rhythmic, sloshing heartbeat of its deep interior. The giant planet is not a solid, placid ball of gas. Deep beneath the swirling cloud tops its core oscillates. It pulses with deep resonant frequencies, modes of vibration that are utterly imperceptible from the outside. Or so we thought. What this investigation has proven with breathtaking clarity is that these internal convulsions, these deep planetary sighs, do not remain trapped within its depths. They radiate outwards, translated into the language of gravity. The planet's own gravitational field subtly flexes it, quivers in time with that inner rhythm, and the rings listen. They are a cosmic seismograph of unimaginable scale and sensitivity, recording the faintest tremors from the planet's core. The particles of the C-ring, in their perfectly synchronized dance, are nudged by these gravitational ripples. Over millennia, these tiny, persistent nudges build up. They create the very spiral patterns and resonant gaps that Cassini so beautifully documented, the very features we initially and incorrectly attributed to an outside force. Saturn, in a very real sense, is singing to its own rings. and its song is one of geology, physics, and deep time, a song of its own internal dynamic life. This discovery has fundamentally rewritten our understanding of the relationship between a gas giant and its iconic jewelry. The rings are not just a companion to the planet, they are an extension of it, a visible expression of its hidden soul. But where then does our interstellar visitor 3I, Atlas, fit into this new epic? Its role was transformed from that of the lead actor to the crucial illuminator. While the comet did not create the ripples, its unique trajectory as it passed through our solar system caused a subtle but critical change in the system's gravitational equilibrium. Think of it not as a hand plucking the harp strings, but as a sudden change in the humidity of the concert hall, a change that subtly alters the tension and tone of every string at once. The comet's passage slightly perturbed the orbits of Saturn's moons, those powerful gravitational shepherds that maintain the ring's sharp edges. This perturbation, in turn, altered the precise resonant locations within the rings, causing the pre-existing patterns, those echoes of Saturn's core, to shift and become momentarily more pronounced. It was a fleeting alignment, a chance coincidence of celestial mechanics that briefly turned up the volume on Saturn's internal music, making it just loud enough for us to finally notice. Without the comet's flyby, that subtle signal might have remained buried. Without the mistaken hypothesis about its direct influence, we never would have looked so intensely at that exact moment in time. Serendipity, it seems, is as fundamental a force in discovery as gravity itself. We were gifted a cosmic coincidence, a perfect transient alignment of an interstellar object, a deeply resonant planet, and our own vigilant machines, all conspiring to reveal a truth more complex and beautiful than we could have ever imagined. This revelation sends its own ripples through our understanding of the other ring giants in our cosmic backyard. If Saturn's rings are a Rosetta Stone for its interior, what are the faint dark rings of Jupiter, Uranus, and Neptune telling us? We've long seen them as pale imitations of Saturn's grandeur, tenuous and ghostly by comparison, but now we must see them as new scientific frontiers. Are the strange kinks and braids in Neptune's rings, the so-called arcs, not just the work of shepherd moons, but also expressions of that planet's own deep, turbulent heart? Is the tenuous dust of Jupiter's ring system, constantly replenished by its inner moons, also vibrating with a song we have yet to learn how to hear? This discovery provides us with a completely new toolkit for planetary science, a method of performing celestial seismology from millions of kilometers away. By studying the fine structure of these distant rings with future probes, we might be able to map the unseen interiors of these worlds to understand their cores, their layers, their evolution, without ever needing to plunge a probe into their crushing depths. The rings have become our remote sensors, our planetary stethoscopes, and the implications of this extend far, far beyond our own solar family, out into the vast, star-dusted darkness of the galaxy. We stand at the dawn of the age of exoplanetary science. With instruments like the James Webb Space Telescope, we are just beginning to glimpse the worlds orbiting other stars. We know that gas giants are common out there, and where there are gas giants, there are likely to be rings. Imagine for a moment a super Saturn in a distant solar system, a planet adorned with a ring system 100 times more massive than our own. What we have learned here gives us a new way to study such a world. We can now model how the oscillations of an alien gas giant would sculpt its own magnificent rings. When we analyze the faint light from that star, looking for the telltale dimming as the planet and its rings pass in front, we can search for more than just their size and shape. We can look for the subtle signatures of resonance, for the telltale gaps and waves that betray the rumblings of the planet's core. We will be able to deduce the internal structure of a world light years away simply by reading the story written in its rings. They will become proxies for planetary density, composition, and even age. Furthermore, we can now predict what to look for as interstellar objects like 3I, Atlas, careen through those alien systems. The passage of a rogue planet or a visiting exocomet could cause a temporary detectable flare-up in the brightness of the rings, a brief change in their resonant signature. Planetary rings across the galaxy may not just be beautiful passive features, they could be active billboards announcing the presence of unseen visitors. Saturn has given us a key, a way to unlock secrets not just about itself, but about the nature of planets everywhere. In the end, our story comes full circle. It began with an object from the stars' 3i, Atlas, and it concludes by giving us a new window through which to view the worlds around other stars. The initial misinterpretation was not a dead end, it was a portal. It taught us that the cosmos is an interconnected system, a place where the faintest gravitational whispers can carry information across unimaginable distances. It showed us that the universe is not just a collection of isolated objects, but a web of subtle and continuous influence, where the sloshing of a planet's hidden core can be momentarily illuminated by a chance passerby from interstellar space. We are explorers on an infinite ocean, and our instruments are becoming ever more sensitive. We are learning to see beyond the obvious, to listen past the noise, to appreciate the profound beauty hidden in the quietest of signals. The sensational headline was a siren's call luring us towards a deeper, more resonant truth. And it is this truth that will guide the next generation of explorers as we point our telescopes towards new rings around new worlds, listening for the secret songs of alien planets forever changed by the story of a distant comet, magnificent planet, and the symphony they accidentally revealed to us. The search continues not for the simple answer, but for the next more beautiful question.